Thank you, thank you. Fortuitous to have that panel and then how I want to start my presentation, and that wasn't planned. But I'd like to ask for a little audience participation here. I want to read an account for you, and I'd like you to see if you can tell me anything about this accounting, when or the product or anything. Yesterday, an experimental unmanned heavier-than aircraft of substantial size producing only water as exhaust, flew for 90 seconds. The chief scientist advisor stated the aircraft performed remarkably in a stable flight. Anybody want to hazard to guess what that accounting was recollecting? Give me a year, a product, a decade. Who said it? 1970s? Somebody else? There's a hand in the back. Trey, you earned some swag. I'll send that to you when we get back. You're the closest. That was from May 6th, 1896. The accounting was by Alexander Graham Bell and a product that was produced by Samuel Langley. You guys have all heard of the Langley Research Center? So interesting. As I was preparing for this, learning a little bit, I'm a bit of an aviation history buff. I think it's really fun to learn where we came from because it helps guides where we go in the future. But he was chiefly an astronomer, and he also was interested in aviation. And as he was developing this thing, it was a steam-powered craft, and it flew for 90 seconds, 3,300 feet. Subsequently, the Wright brothers, you guys remember how long the Wright brothers' first flight was? 12 seconds, right? Samuel Langley was also played in aeronautics, but he really was not a very good one. This formula that you see here is not just to put a formula up there to seem like we're talking about something really complex in math. That's actually the formula in the FAR Part 29 regulations for rotor loads analysis that's required for Part 29 aircraft. What he missed is that his data told him that as an aircraft got heavier or flew faster, the loads reduced. And of course, we know today that that's opposite. And that's relevant because the investable assets that you are interested in, the investable assets, are larger aircraft, right? So that was a miss on his part. But where Langley was really interesting is he monetized time zones. And I know I'm kind of off on a trivia thing here, but there was a Canadian railroad engineer who came up with time zones. Langley took his astronomy and said, let's use that to monetize a subscription service for the railroads that regulates astronomy to time zones and broadcasts that through telegraphs. So much like we are here in investors and finance, he monetized that issue of time zones. So that was a long time ago, right? 1896. Just 46 years later, a relatively short time in terms of innovation, we had the first helicopter delivery. Many of you participate in helicopter deliveries, right? This was the first helicopter delivery ever, as far as I can find. And it was in May 1942. That was the first military rotorcraft ever developed and delivered to the military. That's Igor Sikorsky, Orville Wright, and Lieutenant Colonel Gregory. You may not know Lieutenant Colonel Gregory as well as the other two, but really we're standing on the shoulders of these giants way back in the day before they even had color photography. So I mention all that to show how far we have come in a lifetime. And I guess that depends on whether you're cool deep and you're still very early in your life or you're somebody like me who's getting on in years, right? But that's arguably a human lifespan, right? And we went from the first certified commercial rotorcraft, the Bell 47, to now 2025, where we can fly, where's Simon, in any weather. Search and rescue, and transport category rotorcraft. This is a massive, massive lift across the industry. And I enjoy talking to this group because we're all part of a symbiotic ecosystem, right? And when we look at how far we've come, that's where you guys come in. You guys know this guy, Rocky Bjorn? If any of you are lessers, this is your alter ego. He can balance anything, right? You can go look at this guy on YouTube. And that's kind of what I've heard a lot of the discussion today talking about is you're managing a fleet. Brad talked about configurations, right? The fielded fleet, moving an aircraft from one to another, market changes, cycles, and changes in technology, right? So what I want to focus on today is some areas that I feel are very relevant to how technology and innovation will affect us and how we should focus that effort on the things that really matter in terms of rotorcraft. So that'll be our aircraft, our crews, and our maintainers. And I promise that's the only Top Gun references I have there. So when I first came back to Bell, I've been around helicopters my whole adult life. And I spent some time here before, then I went to Sikorsky and I came back. And the 525 was still in development, and I said, I need to learn about fly-by-wire. And unless you come from one of these other fields that you see referenced here, we really don't know fly-by-wire. One of the early conversations I had with a customer, he asked if that meant there's cables that connect the control surfaces. And at first I thought, wow, what a silly question, but then I thought, wow, that's really not, right? A lot of people don't understand what we're really talking about. These are computers that are operating through cables to manifest themselves in the flight control actuators. So that happened. This spidery looking guy you see up here is the Lunar Landing Rover training device. So you remember back in the 60s, the Apollo missions, and Larry Bell was working with the government, and he said, look, you guys need a training aircraft to train these astronauts to fly this lunar landing rover that's going to go down to the surface of the moon. They created this thing, and this is the first solely fly-by-wire aircraft to ever operate in Earth's atmosphere, 1962, right? And interestingly enough, it wasn't flown by a test pilot. It was flown by the mechanic. He went out to do a thrust check on the engines and accidentally flew it for 30 seconds. But if you look across the industry, that then moved into a government development program, then made its way into my friend's Airbus on the fixed wing side, brought it into Part 121. Then Boeing followed them. It has made its way into corporate aviation. My friends from Leonardo, it's in the 609. On military rotorcraft, there's not a program that's come out in any recent year that's not a fly-by-wire aircraft. And then Bell is now working to bring fly-by-wire into the civil certified space. And as you heard the last panel talk, certification is a Herculean task to accomplish, right? So that's kind of a little history of fly-by-wire. But where I really wanted to focus is why fly-by-wire matters. So I'm going to hopefully shed a little light here, and maybe this will be useful for you as you go on your own journey of understanding why this matters. This chart is one that I'm still working on, but you kind of read it left to right and top or bottom to top. So if you look at the Heli Offshore Safety Performance Model, this is looking at where our safety issues are in rotorcraft. And this is not a mystery why we have accidents in rotorcraft. It is a very well understood problem. And when you have an understood problem, you can engineer a solution to that issue. That's what we do as aviation engineers, as aeronautical engineers. So the reasons why we have issues with aircraft, the predominant issue, the largest issue, is system failures. That's where we as OEMs can have the biggest impact by changing the reliability of the components on the aircraft. The next two issues are flight related. It's controlled flight into terrain and loss of control in flight. So as you come to the right, the way I kind of understood this in my own mind was a picture of fly-by-wire as a foundation, right? It's not a silver bullet. It doesn't mean anything in and of itself. It's how it's applied as a system to the aircraft to work on those three issues. So the first thing it does is when you move to a digital fly-by-wire system, you move up in standards, in regulatory standards. We have to go to 10 to the minus 9th demonstrated reliability on all the systems, the primary flight control systems. That's 1 in a billion, right? Any other aircraft control system is 10 to the minus 7th. So it's a substantial change. And then we look at integrated vehicle health management. This is telling us the aircraft talking to us and telling us the condition that it's in before it breaks. Low speed, low heat drive system is another OEM function that we can use to start to remove failure causes from the drive system. And then as we get into that, we're really going to start talking about the changeover from the air vehicle to the human-machine interface and the cruise. So this is a view from the cockpit of that first certified rotorcraft, the Bell 47. And what do you notice there, right? Not a whole lot of instrumentation. It's mostly a visual flight operating environment, right? And I'd also ask you, next time you're sitting around with nothing to do, just sit in a chair and try to hold your hand the way he's holding it in that control mechanism. How many pilots are in the room? Rotorcraft pilots. Yeah, your arm gets tired, right? The first time I ever flew a helicopter, the flight instructor says, look, figure out how to lean over and rest your forearm on your leg so you don't get really tired. Simon's nodding his head like, yep, that's what we do. It's a basic flight control mechanism based on visually flying the aircraft. This is a modern flight deck, right? And I'm going to zoom out here in a second, but I put this in because what's one of the most visually grabbing pieces of information that you see in that picture? Shout it out. It's that kind of dark, you really can't see it. Here's my laser. For me, it was that right there, right? What does that tell you? When one of the most visibly grabbing pieces of information on the flight deck is the no smoking sticker, right? But this is a very different environment. This is the flight deck of the Bell 525, and notice how they're sitting. These are side stick controls. So as we move into the crew and analyzing loss of control in flight, controlled flight into terrain, the human factors engineers will tell you there's a hierarchy of what the human brain can endure, what it can process. And I'm an endurance athlete from time to time, and I can tell you as my pain level starts going up, my focus gets narrower and narrower. As a crew gets less comfortable, they're less able to focus on the mission at hand. When you're focused on, it's too loud, my teeth are rattling, I'm tired of being hunched over, I'm tired of holding my arm this way, it's harder and harder to concentrate. So in the human factor environment, as we focus on the crew, we've now given them side stick controls because we no longer have to worry a whole lot about the control mechanisms going down through the floor and up to the broom closet and up to the flight deck. Look at how they're sitting, right? They're both upright in a chair. They have armrests. You know there's cup holders in this aircraft? They each have 2 cup holders. But they're able to sit comfortably in a low vibration environment. I'm not going to go a whole lot into all that kind of stuff, but that's a much more conducive flight deck to allowing the pilots to do what the pilots need to do, which is manage the mission and have the mental capacity to process an emergency if and when it happens. So now we're going to move into the maintenance portion, and there should be a video. No? No video? Okay, we're not going to have a video. So picture in your mind a video that was really cool. And what we're going to talk about with the maintenance portion is people learn differently today, right? When I talk to young engineers, young maintainers coming into the aeronautical space, the rotorcraft space, they don't learn the same way I did, right? I got handed a stack of manuals, a NATOPS, NAVAIR or NATOPS manual for the CH-53 and said, here, go read this book. Here's a written test on this book. People don't learn that way anymore, right? I learned how to do sheetrock, drywall, watching YouTube videos. That's how we learn new skills today. And so when we're designing learning mechanisms for new aircraft with new technology, we have to teach that differently. And in our aircraft, the 525, we've taken learning from the V-22 where we had an interactive electronic technical manual that is taking data from the aircraft and giving that to the technicians in a way that's more easily understood. You don't have to flow from a maintenance manual in paper format, working through the troubleshooting checklist, and then go to an IPB and try to find the part that it referenced there, where they put it in the IPB. This is all now together in one piece of information that is in a format that goes on your phone in your pocket. This takes and highlights to them from a fault code in the aircraft, a component like a connector that says, go check this pin on this connector, and then takes them straight to the IPB to show them where they need to order that part if they need to. So this kind of now starts to work into the ecosystem and how we can solve a lot of the problems with technology that are really, really big problems for us as an industry, including you as lessors and financiers. When your aircraft aren't flying, it's not good for anyone. So when you look at the high consumption rate of helicopters and this manual system that has been in place for a long time about how we forecast parts, we talked about the supply chain readiness, and it's a long supply chain. When you look at an OEM looking to build an aircraft, we're planning for an aircraft to come out the factory door on one end. That planning needs to start 5 or 6 years before that. That's a long time. And spare parts have to be predicted along that same path. So when you have these process risks, these handoffs that are manual, you have a whole lot of room for error and missed forecasts, right? Chances that are not accurate. And what that results in is, do you have stock at the end? Maybe, right? Sometimes you do, sometimes you don't. Our suppliers, we call it whipsawing, right? They have increased orders, decreased orders, increased orders, decreased orders, because the information is always changing. Technology can help us here. These aircraft now are behaving more, and it's not just the 525. My other colleagues and other OEMs are getting much better at this as well. But moving to an aircraft that talks to us, that tells us, this is what I'm doing every day when you come home. This is the flight hours I perform. This is how my systems are functioning. We now have better data that can then flow seamlessly across the whole value stream to tell us what's going on with that aircraft. It can do it in real time, right? Many of the aircraft now, the modern aircraft, can broadcast information through satellite communications networks to tell you if there's a HUMS issue, a vibration issue. But within the 525, what we're doing is we're bringing that all the way across into a system we call Mission Link. And where that's going to help us is that where the goal is to have no maintenance tasks that can't take place on an overnight shift, right? So when you come back at the end of the day, you're already getting data from the aircraft that goes into analysis, HUMS trending, unscheduled and scheduled forecasts to update them in real time. And these are all automated systems that just get monitored by humans and interjected when they need to be. The maintenance crews are working on this with IEDM fault codes, so they're not guessing and spending hours and hours and hours trying to troubleshoot. Oh, it looks like we have the video, all right? So, and then you move into the start of the next day and you're back in flight operations. So we'll show a quick video here.
The Bell 525 is a brand new aircraft. Bell customer support and our support of the aircraft is not.
We have a reputation to uphold with our aftermarket service, and I can assure you that it's been many years that we've been working our entry into service plan.
Maintainability we addressed from day one.
525 is going to be easier to maintain because of the levels of technology built into the systems. A mechanic is able to troubleshoot very quickly what's going on with the aircraft. They can diagnose and identify the parts required to go repair or maintain the product. You're going to have more accurate and predictable maintenance procedures that are required. Ultimately, the net result is less time on the ground, more time flying.
The 525 is completely built for a digital presentation of information from the ground up. When we're writing the procedures, it's with a electronic delivery in mind. We do it in a format that you can put into your pocket and carry with the aircraft.
So the simple fact that you have a fly-by-wire system gives you more longevity from a maintenance standpoint. You have a lot less mechanical parts that can fail over time.
We've taken a concept of a interactive electronic technical manual and made that real. Go to a 3D model that shows you for every single component on the aircraft, it'll show you exactly where it is in 3D space. And from the diagnostic system, it's 4 clicks instead of 4 sets of manuals. So we put a lot of information that's a click away when you need it.
The system that Bell has built into the 525 is truly giving us this ability to have the aircraft tell us what's going on with those systems. And then we have time to plan and react to those changes that are happening in the aircraft, so that we don't have unscheduled failures. The aircraft is going to give them codes that flow through into their publications so that they can do fault isolation and understand how to perhaps repair that component, or if needed, change those components out. That's allowed us to streamline the maintenance tasks that have to happen to the aircraft when it comes back from its mission. And I think that's really something that's going to resonate once the aircraft gets into service, when people see how different this aircraft is to maintain because it's so easy.
We have a long legacy of just excellent customer service within Bell through our product support engineers and our customer support team worldwide, and our resources to support the introduction of new aircraft. It's not going into greenfields, it's going into a very rich support environment. And the 525 is joining a great legacy of Bell.
So the pictures that you saw there, those are actually from the maintenance manuals, the IETMs, the Integrated Electronic Technical Manuals for the aircraft. And that's what's going to help feed this system of automated data flow so that we can plan better for that maintenance, which flows into our supply chain. The more information we can predict to our supply chain that's an accurate forecast of what they need, the more they can capacitize to have spare parts available, because we're going to consume them. So I hope that that's a good overview. It's not meant to be specific to the 525. These are areas that I think we as OEMs can contribute more to the industry as we go through this. And somebody mentioned the 5 C's earlier of credit. These are the 3 C's of technology and innovation, maybe, that we can remember, is that we need to change the system failures condition. This is critical for us as an industry and as OEMs to really move the needle on this. We need to create a better crew environment so that we make it easier and have a higher probability of success for our crews that are operating these aircraft. And from a overall industry perspective, we really need to connect this ecosystem of forecasting and understanding how to support our supply chain so that we don't have unutilized assets sitting on the ground while we're all still paying for them, right? And lastly, if you have not read this yet, and you enjoy aviation history to any degree, this is a really good read and has a lot of information. My copy is filled with highlighter of things that happened to the Wright brothers that are still things that we need to work on today. Okay? Thank you.
With pictures of the 525. Can you give us an update on certification, when it's expected?
How did I know that was going to be the first question? Yeah.
I was bound to.
So when I came to Bell, I kind of read through the list of different dates that we had given the industry on certification. And I think I'm not saying anything that you couldn't guess already, is that we really can't predict that date with any degree of accuracy. So what we've moved into is a mode of telling you what we have left to do to certify. And there are really 3 things left for us to do. We have no technological issues with the aircraft. Those have all been resolved. The 3 things we have left to do are 2 tests in our simulation lab. They're called Avionics RASL and FCS RASL. When we finish those 2, those are the last 2 things to do for certification, and then we can enter what's called functional and reliability testing. This is the final phase of certification, where you're essentially operating with the maintenance manual, with the flight manual, and you're flying 150 hours with the FAA, just validating that the system works as it's supposed to.
Okay.
Once we finish F&R, then it's into final reports and submittal to the FAA requesting the type certificate.
Okay.
So how long that will take, we'll let you know.
I'll fetch a piece of string and we can measure it. Why has certification taken so long?
That's a great question. Sorry to see that it's an anonymous question, but that's okay. So here's the thing, is everything gets done to a regulatory environment. We're working under FAA Part 29 certification. This is the first civil fly-by-wire helicopter ever attempted to be certified. There is no Part 29 rotorcraft regulation that dictates this is the standard that you have to demonstrate compliance to. So our certification plan with the FAA has to have components of fly-by-wire taken from the fixed-wing community combined with Part 29. We're essentially writing new code for Part 29 certification. So that means that we're charting new territory. There's an old saying, I'm a U.S. Marine, the first guy through the door always gets bloody. And we're living that right now. So it's the creation of the certification standard for digital fly-by-wire Part 29 rotorcraft.
Okay. Thank you very much, David Martin, Senior Commercial Manager, Bell Flight. Thank you.
Thank you.